Hi guys, welcome to the DSD classes. In today's class, we are going to discuss about program structure of VHDL. So HDL, in previous classes we have discussed about HDL. HDL is hardware description language. It is a language which describes the behavior of hardware. So HDLs are two types, VHDL and Verilog. So VHDL is one of the hardware description language where VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. It was developed in 1980s. So the structure of VHDL can be divided into two major parts. One is entity and second one is architecture. So what an entity will give is, an entity declaration describes a component's external interface, means it will give the information about input and output ports. So for any block diagram, how many number of inputs and how many number of outputs. So this information will be given by an entity, whereas an architecture describes its internal implementation, internal structure of an VHDL. Right? So entity describes the external signals, whereas architecture describes the internal implementation. So this is the block diagram of program structure of VHDL. So a program structure is two parts, entity declaration and architecture declaration. So where an entity can be shared by many number of architecture. So right, where it is entity, architecture. So this is entity B and architecture B. This entity and architecture can be shared by architecture B. So this is the block diagram of program structure of VHDL. So coming to see the syntax of entity, how we can write the syntax of an entity. So mainly entity is used to specify the input and output ports of the circuit. So as I discussed earlier, entity is declaration of the external signals, which are nothing but outputs and inputs. So an entity usually has one or more ports that can be inputs, outputs, in-outputs and buffer. Right? This is the syntax of an entity. Entity starts with the keyword. This is a keyword. Entity starts with the keyword entity followed by entity name is port, signal names, colon, mode, signal type. So here we have whatever the words in bold letters, this shows the keywords and these are user identifiers, right? So entity is port, mode, signal type, end. These are the keywords, whereas signal names and entity name is user identifiers. Any programming language has keywords and user identifiers. Keywords are defined by the libraries, whereas user identifiers, name itself indicates that user identifiers defined by the user. If we want to give a name to the entity, we can give our own, but we have to follow some basic rules for giving this user identifiers. So any user identifier starts with a letter followed by numbers, digits, whatever it may be. Starting character will not be underscore or number or other symbols. It may be only letters, A to Z letters. So next one is, so what is entity, what is entity name is, we can see. So the following section describe the different elements of entity declaration. Entity name, so it is an user identifier. So it is an identifier selected by the user to name the entity. So we can give a name to the entity. So whenever we want to call that entity, we can call by that name. So next is signal name. It is a list of user selected identifier to name external interface signals. So means what are the external signal means inputs and outputs. So we can give names to the inputs and outputs. So these are also user identifiers. Next is mode. We have different types of modes. So we have four types of modes: in mode, output mode, in out and buffer. So in represents the values of an input port can only be read within the entity model. So right, name input means we can read that value. Output, so whatever the signal names we have written in output mode, these are all output variables. So we can write the data to the output value. So third one is in-out. The value of a bidirectional port can be read and update within entity model will be used as in-out mode. So last one is buffer. The value of a buffer mode can be read and updated within the entity model. However, it is different from the in-output mode in that it cannot have more than one source. So we can have only one source in buffer. So this is about entity. So entity can be defined by entity keyword followed by entity name is port. So port we can write signal means external signal input and outputs, and entity name. Whatever the entity name we are written here, same name can be write here also. So this is about entity. This is an example how we can write an entity. So suppose this is an example of half adder circuit. So a half adder is a combinational circuit which will add two binary numbers. For that we have two inputs and two outputs. So this is an entity for this half adder. So entity followed by entity name. Here we have written half adder is port. So for this two inputs, so A comma B, mode in mode. So we read the values in A and B. So these two values are bit type. So we have to write signal type. So signal type, we have different types of signal types: bit vector, STD logic, integer, character. These are the some of the signal types. So in binary circuits we usually use bit type or bit vector type, and we have two outputs, sum and carry, sum carry colon mode. These two are output, so we have to write out mode. So these two are also signal type bit types, bracket close semicolon, and an entity name. So this is an example for an entity. So entity name is port, input variables, mode in mode, and signal type, and an entity name. So this is about entity. So next one is nothing but architecture. So the internal details of an entity are specified by an architecture body using any of the following modeling styles. So what is the entity means? Entity will give the information about internal details. So what gate we are using, all this will be given by architecture. We can write architecture in three styles. Either it may be structural style, as a set of interconnected components is a structural style. Second one is data flow style. So as a set of concurrent signal assignment statements to represent data flow style. Or third one is as a set of sequential assignment statement. So it is behavioral style. Or we can write a VHDL code, any combination of the above three also. So what an entity is, entity will give the internal details of an architecture. Architecture will give the internal details of the entity. So this is the syntax of an architecture. So any architecture starts with the keyword architecture followed by architecture name of entity name is. So whatever entity we want to call, we can call that entity using the same name is declaration. So we have different types of declarations here. So either signal declaration, variable declaration, component declaration, function definition, procedure definitions. These are the some of the declarations. So we have to define, or we have to declare those declaration before begin keyword. So after that we have begin, and these are the concurrent statements and architecture name. So the same architecture name. So this is the syntax of an entity. I am repeating again, architecture is the internal declaration of the entity. So any architecture starts with the keyword entity followed by architecture followed by architecture name of entity name is declaration, begin, concurrent statements, and architecture. So we will see the example. So same example for the half adder we have written already in entity declaration. So the architecture of that half adder is, architecture is a keyword, architecture name, half adder of. So entity name is same as the entity where we have written previous example, entity name. So this is an entity name. So here we have written half adder, same half adder is we are using here. So architecture half adder is begin, So what is sum? Sum is XOR between A comma B. So sum gets, we can call this as gets, sum gets A XOR B. This is nothing but a logical operator. I will discuss operators what we are using in VHDL in coming lectures. So sum gets A XOR B and carry. What is carry? Carry is AND between A comma B. So carry gets A and B and half adder. So architecture name. N architecture name is half adder, so N architecture name. So this is an example for half adder, how we can write entity architecture. So I will repeat once again. So in this video lecture I am discussing about program structure. Program structure has two parts, entity and architecture. Entity will give the information of ports. Ports are nothing but inputs and outputs, and architecture will give the detailed internal implementation. So entity, we can write entity like this. Entity name is ports and architecture, whereas architecture we can write like this. Architecture name of entity name is declaration begin, internal declarations. So those are called as concurrent statements and architecture. So thank you so much. I will explain remaining topics in coming lectures. Thank you so much.